So I want to estimate the value of the American option, and I'm going to go into Volupta and retrieve some C++ code for Leisen Reimer. And there's a Leisen Reimer Binomial Tree which is quite efficient. There are a couple of trees here developed. There's trinomial trees and so on. There's Cox-Ross-Rubinstein. But one particular tree that looks very promising is Leisen Reimer. So let's just take a look at the code. And it's a C++ code, and I'll copy the file. So I just highlight the text and right click copy, and I'll go into Visual Studio and we'll start a new project, and we'll just very simply call it Leisen Reimer, and we'll say with dividend in this instance. Now, as it turns out, in the code provided in Volupta there's no dividend, but we'll make some changes. And next, and important here to make it an empty project, and takes a little while. And we need to add in a source code. So add new item, and we can just leave it like that. Don't need to make a change here, and we'll add, and I just basically paste. Okay, so at first, looking at it here, there are some issues, right? We can see a little bit of red appearing, and they may be simple to deal with. Okay, so first things first, normally if I use a double slash, I can resolve some of these issues. ms corlib dll, okay, I don't think we really need that, so we can just neutralize. And in addition here, okay, it's not, the max is unidentified. Okay, so a couple of things we could do. We could write some additional code to make it recognize the mass function, or we just could copy, paste, and put in algorithm here, and once the algorithm is included, the max function should be able to work properly. So no, the red markings have disappeared. Okay, so we have these values here now for the option. So if the spot price was 30, K was 30, the time period on the option was half a year, the risk-free rate 5%, and volatility was 30%. If we ran that, would we be able to output some option values? As it turns out, with the code that we have here, we would be able to get a European call, European put, American call, and American put. Okay, so let's just execute. So debug, and there's no errors. A debug window actually did flash, but disappeared straight away. So if we want the output to remain available to us in a debug window, I'll put double slash here and then include system, open bracket, double inverted commas, and then pause and capital letterings, and then a semicolon. Right, and we'll try again. We'll run the debug window. Okay, I'll have to pull it in. The debug window actually is available, and we're getting values for the European call, put, American call, American put, and the value of the European call and American call are the same. So that's consistent with theory where there's no dividend yield. The American call and European call are exactly the same values. Okay, so I'll close that down. And well, I might like to verify some of the numbers here, and to verify is the code executing properly? Am I getting reasonable values? Okay, so one possibility here is to one very simple way to verify the code is to look at use the Black Scholes model and make a comparison. I have some Black Scholes the Black Scholes formula here, and I have the value of the option expressed in terms of a manual formula that's written in, and then some VBA, right? So if we're to look at the Black Scholes call, this is the standard notation that's used, so S, and sometimes instead of using K, I use X, but we have a D1, a D2, and so on. So if we had these values, 100 for S, 100 for K, 0.05 for risk-free rate, 1 year maturity sigma, or volatility 20%, the value of the option will be 1045. I verified that in VBA. I downloaded code from Curryback, and this is code that you can retrieve from the Curryback website, and basically everything looks fine. When I invoke this function, the value that I get is exactly the same as here in the spreadsheet. So 1045.05.836. Okay, so let's see if I can memorize those values. Go back into our C++ program and set out value. So the spot price, we're going to say, as before, was 100. The exercise I'm going to take here as being 100. The time period, okay, 1 year, 1 full year. Risk-free rate is 5%, no dividend yield. Volatility 20%. Okay, let's run this using 100 steps. And the output that I'm getting is 1045.06. Looks quite familiar. Let's close that down. We might do one small little adjustment here for the C out. We could set precision. So there's a command we can put in. So set precision, and then we would have 10 precision. SCISION, and we'll say 10. So we should get 10 digits appearing. And again, we need this. Now we're missing something. We've to include. So we can copy and paste again. So for that, to invoke that set precision command, we need to just make one change here. IO manip. So in out stream manipulation. Okay, so let's see, is that gone? Okay, so the red sea of red we had down here, it seems to have lifted. Let's run this again. And okay, this time we do get a set of values. So we'll copy. So edit, select all, and then edit again and copy. And we can go back into the spreadsheet, and we'll just paste in the output, and we'll make some comparisons here. Right, so the European call using Leisen Reimer turns out to have, when you put in 100 steps, you get it has to be an odd number, so 101 steps. 1045.06, 1045, 0858. Okay, so it's relatively close. It's in that region. What we could do is just do one more trial here. Go back into Leisen Reimer again. We'll use 300 steps, perhaps, just to see can we improve our level of accuracy. And we'll run one more time. And we'll bring over, and again so 301 steps this time. Edit, select all, edit, again, copy, and go back into Excel, and this time here we can paste beside, paste, and 1045,058, so 58. Okay, so you can see that at about 300 steps we've moved out. In terms of accuracy, we're a little bit closer again. And again, in this instance, we're using a tree type binomial tree, whereas here we've the Black Scholes closed form solution. Okay, so 300 seems to be giving us a reasonable level of accuracy, at least for the European option. Okay, now for the American option, we don't have a closed form solution that we can make comparisons against. And in that instance, we're probably better off going to the literature a little bit and having a look at particular values. So one place I will initially go to is to Brody and the Temple, and this paper is from 1996, and it's the Review Financial Studies, and again on page 14. So on page 14 there's a useful table, and now it's not arranged in a way we can easily see, so I'll copy and paste that into a spreadsheet, but I'm going to have a look at table 1 here, which is page 1223. And I've that already pasted in to this spreadsheet. Okay, so we have some parameter values, different levels of S for particular R, sigma, and dividend, I presume, and then we have true values, and these are true values for the American option. Now note the true value is the Cox-Ross-Rubinstein value, but at 15,000 steps. So the true value column is based on the binomial method with n equal to 15,000 steps. Okay, so we can do we have a way of verifying our results, and the results we obtained for the output for the American option, right? Only thing here is there's a few issues. First of all, in the code available from Volupta, right, there's no parameter specification for Q, so we've got to change that, and that's going to require a number of small changes as we go down along. And secondly, the parameters are different. Okay, so we'll have to update these parameters. First things first, if we're putting in a dividend yield, we'll have to specify down here. So I'll return from here. So we'll have to put in a double. We have to declare the dividend yield and give it a value. Q is equal to 0, and don't forget the semicolon. And in addition, then we need to, we make a note, I suppose. So it's new. I would say dividend yield. Okay, so it's something new. When we come down, also, as it turns out, we don't actually need these two. So if we take out with forward slashes and run and come back here and neutralize and debug, okay, we get results that are unaffected. So the fact that we have removed these two doesn't in any way prejudice the estimation. So in the next video, I'll incorporate in the dividend yield and compare against Brody and the Temple 1996.